Okay, so this is an example of an application of a sinusoidal function. And in this case, we have a Ferris wheel that is moving around in a circle. And we're saying that the height of a car on the Ferris wheel will model this sinusoidal function. And if you can just think about the height of the Ferris wheel. Say you get on the Ferris wheel at the bottom, then you're going to move to the top, and then you're going to move back down to the bottom, and then moving up to the top. And you can see why that might be able to be modeled by a wave function. Okay, so in this case, we're going to try to make sense of the context. So let's read the situation. A small Ferris wheel that has several passenger cars is moving in a circle as shown in the figures. When the Ferris wheel reaches a constant speed, a stopwatch is started so the time is t equals 0 seconds. When t equals 0, car A is at a point halfway between its maximum and its minimum heights, 2.5 meters above the ground, and going up. So it's moving this direction, right? Okay. Car A first reaches its maximum height 4.5 feet or meters above the ground when t is equal to 2.5 seconds. When t equals 10 seconds, car A is back to the halfway point between its maximum and minimum heights. The Ferris wheel continues to move in a circle so that the car's height over time can be modeled by a sinusoidal function. Okay, so we're asked to graph the function. And in order to do that, it might be helpful for us to come up with a table first. Okay, so let's see what information we're given. We know that when t is equal to 0, car A is at a point halfway between its maximum and minimum heights at 2.5 meters above the ground. Okay, so the halfway between max and min, that's also known as mid, right? Okay, and that's t equals 0, and the height is 2.5 meters. All right, so then after that, it reaches its maximum height. Okay, so maximum of 4.5 meters when t equals 2.5 seconds. Okay. All right, so let's take a look at that. We know at 2.5 seconds, we're at 4.5 meters, okay? And we also know that when t equals 10 seconds, we're back to that point halfway, back to a mid. Okay, so looking at this, we're going from a mid to a max, which means probably a sine function, right? And we're going up by 2.5 seconds. So I can fill in the rest of my table for t by just adding 2.5 seconds. And we can then fill in the rest of our pattern. We go from mid to max, that means back to the middle, then down to the minimum, and then back to the middle. Everything that is in the middle is going to be labeled at 2.5 meters. And then let's take a look and figure out what the minimum value is here. If the distance between the midline and the maximum is 2 meters here, I need to go 2 meters the other direction to get the minimum, so this is going to be 0.5. Okay, and now we've got enough to kind of look at how to plot the function. We definitely can see, I mean, if I was going to write the function, I know what my amplitude is, right? It's a distance between the maximum and the midline, so our amplitude is 2. We're going up first, so there's no reflection. we can say it's a sine function. And we can write it so that there is no phase shift because we're starting right in the middle on the t equals 0. Let's talk about the period. We can say the period divided by 4 is equal to the increment. So the increment times 4 will give us the period, and that's going to be 10 seconds. And then lastly, our vertical shift. And that's going to be what our midline is. So that's going to be 2.5 meters. All right, so here we go. Let's give ourselves a 2.5 here, and then a 0.5. Stop, sorry about that. And a 4.5. All right, and then we know that this is going to be 10, 5, 7.5, and 2.5. All right, and so it's going to kind of look like this. All right. And then if we wanted to actually write the function, we would need to figure out our b value. So 2 pi divided by b is equal to the period, which is equal to 10. And so b would equal pi over 5. So we could write this as y is equal to 2 times the sine of pi over 5t. And then add that vertical shift, plus 2.5. All right, and that's going to give us what we're looking for there. All right, I hope this helps.